Hi. Oh, okay. So we're going to start differentials. I'm so sorry that I didn't post this last night. I completely forgot until whenever I posted on Schoology. So anyways, differentials. Differentials are called a linearization sometimes. So it will say use linearization, use differentials to approximate something. So again, you're going to use it to approximate a number. So it's a very small quantity that corresponds to a change in a number. Um, so it's the change in x. So we're going to use this right here, the triangle x, as our change in x to denote the differential. And it's, like I said, used to approximate a value of a function or to find the error of approximation. So an error would be, it could be something that's manufactured and it's always supposed to have a radius of 3, but it has an error rate of plus or minus 0.05 or something. So where it's off a little bit. Okay. Recall and formula. So the formula for derivatives. So this goes way back to September. Our general formula is the limit as h approaches 0 of f of x plus h minus f of x over h. So remember, before we even started all the shortcuts to finding derivatives, we used this formula and we would work all the way through it, excuse me, to find our derivatives. And so it comes from that. So basically what we do is we replace h with change in x, which also stands for the really small increment that we're changing, and then get rid of the limit. So it's this same equation that you see up here. We've just replaced the h with the change in x right here, and then got rid of the limit part. So it's no longer equal to the limit because it's an approximation. So even though it is an approximation, as you can see, it's pretty close to being accurate. It's close as we can get without being exact, essentially. So again, remember, you can always pause, do whatever to write it down, but I'm going to keep moving. Okay, so our formula, our actual formula, came from what we saw back here. Sorry, I keep going back. Right here, all I did is manipulate this, and that gives us what we have right here. So it's just through manipulation. The value, it says how this reads. The value of a function at x plus a little bit, because remember, change in x means x plus a little bit, so our tiny bit, equals, or is approximately equal, which is why we have the squiggly, the function at x plus the product of the derivative of the function at x plus a little bit. So it's just filling in all these blanks. So it looks like it's going to be challenging, but it's not too bad. So we're just filling in the pieces and we're going to get a number, essentially. So use differentials to approximate the square root of 9.01. And you will have a calculator in most cases for these. However, if it says use differentials, you must use differentials. You will get a different answer in most cases, or they'll have you round so far that you get a different answer if you just were to type 9.01 into your calculator. So step 1, we need to determine what x, f of x, and our change in x, so our triangle x, will be. So looking at this, what is our function or what is x going to be? So just think about that. So remember, x and f of x, or change in x, I'm sorry, need to add to give us what's here. So we're going to let our x equal 9, and what will our change in x be then? Our change in x is going to be 0.01, because 9 and 0.01 give me what's in here. And then my f of x is root x. So I've taken everything that they gave me in this function and put it into the parts of my formula. Okay, step 2, we need to know our derivative. So what is the derivative of x root x? So that's the same as x to the 1/2. Remember, we're not integrating, we're taking the derivative. So when you take the derivative, you bring the power down and subtract it by 1. So the derivative of f of x is 1/2 x to the negative 1/2, which is the same as 1 over 2 root x. So that's step 2, take the derivative. Step 3, plug everything into our formula. So recall our formula from the last slide. It's f of x plus change in x. So x over here, where x equals 9, change in x is 0.01, is approximately equal to f of x, which is right here, root x, plus f prime of x change in x. So we're going to use our numbers. So we plugged in f of x plus change in x is this. We put it into what we have right here. Okay? Whoops. Then root x, because that's my f of x, and then the derivative of x is this, and my change in x. Next, I'm going to plug in my values so I can solve. So I know x is 9. I know my change in x is 0.01. There we go. Plug in values and solve. So the square root of 9.01, I plugged in 9 plus 0.01, is approximately equal to the square root of 9 plus 1 over 2 square root of 9 times 0.01. So if you plug this into our calculator, a little bit of it we can work out. So we get the square root of 9 is 3 plus 1 over 2 times the square root of 9, which is 1 over 6 times 0.01. So it's going to be 3 plus a little bit, which we get this if we work out this part. So in your calculator you would take, let me show you. So I don't know if you can see this, but I would do, actually let me turn it like this, 1 divided by 6 equals, and I get this, and then times 0.01 equals, and I get this part that we have left over, plus 3. So I kind of typed it backwards just because I'm using my phone as a calculator, and there, you should get the same answer. And then, so we can compare these. So if I just take, I'm going to clear this out. Where's my clear? 9.01, which was my original thing, and take the square root, I get something really, really close. Okay, it starts off the same, 3.00166.2. So it changes. Mine that we did by approximating, it stays 6s. So it's really close, but there is a difference. And if you were asked to do this on the AP exam, they would want this answer, this approximation. So that's why we need to be able to do it. Okay, we're going to do one more example like this, and then there's one other formula. So use differentials to approximate the square root of 9.5. Step 1, determine what x, f of x, and our change in x will be. So this one's pretty similar to the last one. So we know that x is going to be 9, f of x is going to be root x still, and then our change in x is 0.5 in this case. So it's, like I said, it's very similar to the last one, so that not too much changes, which is good because we already know our derivatives. So you don't have to do more work than that. We already know f prime of x is 1 over 2 square root x. Sorry, I know I'm moving fast, but remember you can always pause, and you should pause and try these on your own. Step 3, plug into formula. So we have our original formula. I'm going to have root of x plus change in x is approximately equal to root x plus 1 over 2 root x times change in x. So that's just my general information. Step 4, plug in the values you know and solve. So I'm going to plug in 9.5. It's approximately equal to square root of 9 plus 1 over 2 root 9 times 0.5, which gives me that, which gives me this. So this one actually, I think it's a little bit farther off. So when I plug that into my calculator, I get 3.083 repeating. And if I just take 9.5 and take the square root, I get 3.082207. So it is a bigger difference than our last one, but it's still an approximation, so it's okay. Just notice again that it's not giving you the exact same value. So, okay, there's one last type. So it's called, it says dy, which is just like y equals or a equals in most cases, because these are dealing with area or surface area, equals f prime of x dx. Okay? So used to estimate the error in a measurement or to find the effect on a formula when a small change in a measurement is made. It says, so what this phrase means right here, dy equals f prime of x dx, the change in a measurement dy due to a differential dx is found by multiplying the derivative of the equation for y by the differential. So that's kind of wordy and confusing, but again, we're going to do an example. So, 1. So this is when you have a problem with something more real life, the radius of a circle is inscribed from 3 to 3.04. Estimate the change in the area. You're going to use this formula that we have on this page right here. Okay, so step 1, what is the area of the circle? We need the area of the circle to be able to plug into my formula. So we should all know that the area is pi r squared. Step 2, what was my original formula? So from our last page, my original formula was dy equals f prime of x dx. Okay, and in this case, in my case, I'm talking about my function is area equals pi r squared. So we're going to use, what is our formula with our information? We're going to use this information, area equals pi r squared, to fill this in. So we're going to have dA, because the derivative of a, remember y is just talking about a function, then what is the derivative? So a prime times dr, because I have an r in my formula. What are our values equal? So then we have to determine, so from our problem, what is my radius? What is my change? Okay, so we know the change dr, which is the same as dx, is 0.04. That's our change. We know the derivative of area is 2 pi r, because if I just take a prime, take the derivative, I bring my exponent down, and I'm left with 1. And my radius is 3. It gives me that. So our change is this 0.04, and our radius is 3. Last step, plug into the formula. So I have dA equals 2 pi times 3 times, I should have put parentheses there, times 0.04. And if I work all of that out, I get 0.74. So again, you're just plugging and chugging. Also, this is all in your Princeton Review book on page 136, 137, 138, and 139. So if you have questions, you can always refer back to the book. Everything that I did is from there because I want you to be able to look it up. The next page has try problems per usual. The answers will come up and you may pause them, write them down, work through them at your own pace, look at them in the books, do whatever you need to do. And then the last page is, or last slide is classwork that will need to be turned in. So here's our try problems. There's only 3. Some of them are a little bit different than what you saw, but same concepts. Again, in about 10 seconds, I'm going to post the answers, so what you should be getting, and I would suggest trying them before you go straight to your book or do anything else. So at least try and work through it, and if you don't get the correct answer, then go check it. See what you did wrong. See where you made your mistakes. So there's our answers, spinning around and around and around. Okay, make sure you write those down so you can check your work. And these I will not collect. The try problems I won't collect. Classwork will be collected though, which is on our next slide right here. So those are your classwork, and this is the same as the problems that come from practice set 18 in your Princeton Review book. I didn't use all of them, but most of them. Again, this is due on Thursday. It needs to be done on a separate sheet so you can turn it in. If you have questions, email me, bring it on retreat, whatever you want to do. Okay, I'll see you all tomorrow. Sorry again that this was late, and I will post the PowerPoint on Schoology by itself as well as the video. Have a wonderful evening. See you tomorrow.